We go over general mathematics questions. So for x in the following, we've been given log x in base 2 plus 4 log 2 in base x is equal to 5. How do we get to solve this one? Well, the first thing that we want to do is we want to make the bases to be the same. Of course, we know that log of x in base 2 plus the 4 log 2 in base x, we can also write it as log of 2 to the power 4 and then x, that is equal to 5. That is, we can bring a number that is in front here to become a power of this number which is here. Okay, and this is equal to 5. Now we need to make sure that they are in the same base. As we can see, we have got two different bases. Well, we can either make this one into base x or we can make this one into base 2, whatsoever we want. Now let me make this into base x. So what we are going to do is becomes log, we want it to go to base x, so we just introduce x as a base, and then this one we just write the way it is, x, and then divided by log, we are taking into base x, and then what was the base now comes here, and then plus log in base x. Well, 2 to the power 4, that can be simplified. Now I've just realized there was no need of me even writing the 4 on top there, because the one I'm changing base is another thing. So let me just put it down there. Okay, and that is equal to a 5. Well, we know that if we have got log of x in base x, that is a 1, and so we have got a 1 there divided by log of 2 in base x, and then plus 4 log of 2 in base x is equal to 5. Now what I'm going to do, because I've got log of 2 in base x, log of 2 in base x, what I'm going to do is I'll just make a letter, any letter, just represent that. So say let p be equal to log of 2 in base x. So at this point I'm going to put a p, and here there I'm going to put a p. So that is going to be 1 over p is equal to, not yet equal to, plus 4, where there is log of 2 in base x, I'll put a p, that is going to be equal to 5. Well, I don't want to have anything in the denominator, so let me multiply everything by a p. So 1 over p times p, that is just going to be a 1. Then plus 4p times p, that is going to be 4p squared, and that is going to be equal to 5 times p, that is going to be 5p. Let me write this in the general form of a quadratic equation, which is 4p squared, I take 5 this side, becomes negative. Okay, so minus 5p and then plus a 1 is equal to 0. Now this time I'm going to look for a product and the sum. Well, the product is when we multiply this and this, the product is 4 and the sum is negative 5. So what two numbers can we multiply to give us 4? If we add them, they give us a negative 5, and you know that that should be negative 4 and a negative 1. So this will be 4p squared minus 4p minus p plus 1 is equal to 0. Factorizing out what is common on the first two, that is a 4p, and then a p is going to remain and the 1 is going to remain there. What is common here, I'll just remove a negative 1, and then a p is going to remain, a negative 1 is going to remain, that is equal to p. So you can see these are the same, so I'll just get what are those things which are outside. So I'll say 4p minus 1, p minus 1 is equal to 0. So this means 4p minus 1 should be equal to 0, or p minus 1 should also be equal to 0. Therefore 4p should be equal to 1. That means p should be equal to 1 over 4, and then this side p should be equal to 1. Alright, so those are the solutions then for p. Now remember, we are not solving for p. Our aim is to find the value of x. So we're going to come back, since we have found the value for p. We'll still come back. So we'll say, but we know that log of 2 in base x is equal to p from what we wrote here. So we get the values for p. The first one, log of 2 in base x is equal to, what's the first value for p? It's 1 over 4. And then or log of 2 in base x is equal to p. What's the other value for p? It is a 1. We can express this in exponential form. We know that this is the base, this is the power. So this means x to the power 1 over 4 is equal to, this becomes the answer 2. And then same this one, x to the power 1 is equal to this. So that is x to the power 1 is equal to a 2. Well, to remain with only the value of x here, we're going to multiply by 4, so that 1 over 4 by 4, it will just give us a 1, x to the power 1, which is just x. And then even this one, we're going to raise it to the power 4. What you do on one side, also the other side. So that means x is equal to 2 to the power 4, and 2 to the power 4 is a 16, or x is equal to 2. So these are the two values of x then. Well, let's consider the second one on this problem. So we want to find the value of 4 to the power 2x minus 1 is equal to 1 over 16 to the power, okay, that is to the power 4, 1 plus x. 1 plus x. So this is a 1 plus x. Now our aim is to make sure that the bases are the same. So what we have is 4 to the power 2x minus 1 is equal to, well, 16. 1 over 16 can also be written as 16 to the power negative 1. And then we've got 1 plus x. And so this is the same as 4 to the power 2x minus 1 is equal to, 16 itself is the same as 4 to the power 2. But because of the negative, so it becomes 4 to the power negative 2. And then we've got 1 plus x. And so this is the same as 4 to the power 2x minus 1 is equal to 4. Negative 2 times 1, which is outside there, that is going to give us negative 2 still. Negative 2 times x, that would be negative 2x. Well, now since the bases are the same, we can equate the powers. That means 2x minus 1 should be equal to negative 2 minus 2x. So I can take this side and then 1 this side. So that would be 2x plus 2x is equal to negative 2, the 1 becomes positive. 2x plus 2x, that is a 4x. And that should be equal to negative 2 plus 1, that is a negative 1. So then x is going to be negative 1 over 4. So that is our value then. Let's consider this one. Given that A is equal to that matrix we've been given, find the value of t if the matrix is a singular matrix. Now if we've been told that a matrix is singular, that means its determinant is equal to 0. So we're going to find the determinant of this matrix. So say determinant, okay, this number here is a 2. Determinant of this matrix A is going to be equal to, well, when we want to find the determinant of the 3 by 3 matrix, first we're going to get this number which is here, that is a 1, and then cancel out each row and each column. The matrix which remains there, negative 3, negative 1, 1, 1, we are going to write it. So we're going to write it here. Actually that is a positive 3 and then negative 1 and then 1, 1. And then we are going to get this number which is here, change its sign. So if it was positive, it becomes negative. So we don't know the sign for 0, so we just say plus 0. We cancel out the row where 0 is and the column. So we remain with t, negative 2, 1 and 1. We make a matrix of what has remained. So that is t, negative 2, 1 and the 1. And then we are going to get this number which is here, just the way it is without changing its sign, positive 2. Now we're going to cancel out its row and its column. So you can see the matrix which has remained is t, negative 2, 3 and negative 1. So that is t, negative 2, 3 and negative 1. Well, the determinant of a singular matrix we've said is supposed to give us a 0, and that should be equal to 1 multiplied by anything is 1, so that one just goes. Now we find the determinant of this 2 by 2 matrix. When we want to find the determinant, first multiply these. 3 times 1, that is a 3, and then minus multiply this. Negative 1 times 1, that is the negative 1, but with this negative it becomes a positive 1. Okay, and then 0 multiplied by anything is 0, so I'll not even get interested in this because we know it's a 0. So let's just go on to this one. So first put a 2 plus 2, and then t times negative 1, that is a negative t, minus negative 2 by 3, that is a negative 6. So with another negative which is already, it becomes positive 6 there. So this gives us 0 is equal to 3 plus 1, that is a 4, and then 2 times negative t, that is negative 2t, t times 6, that is a positive 12. So it says 0 is equal to 4 plus 12, that is a 16, minus 2t. I can take the 2t the other side, so 2t is going to be equal to 16. Finding the value for t, t is going to be equal to 8. Okay, so that is the value then. Consider the next question here. In the expansion of 1 plus x over n, so the expansion we've been given is 1 plus x over n to the power n in ascending powers of x. The expansion x is squared is 7 over 16. So that means the expansion x is squared, that is, when we get a number x squared, the question was more supposed to say its coefficient. The coefficient of x squared instead of the expansion of x squared is 7 over 16. So that is the number in front of x squared. Now, what are we going to do here? So the question is, given that n is a positive integer, find the value of n. Well, how do we get the value of n? We've been told that x squared, the number in front of it here, is supposed to be 7 over 16. Okay, 7 over 16. Well, we need to expand this and make sure that we find a term that has got x squared. But what term is that? Well, we need to know that when we are dealing with these expansions, n will always be put there. A number which we are going to put here is going to affect the second term. And so, because we want to have x squared, then we need to put a 2 here. And to expand this, we are supposed first to write the first term. And the first term here is a 1 raised to the power n minus 2. And then we write now the second term, which is x over n raised to the power this same number which is here, raised to the power 2. So I can go on and simplify this. Of course, n to 1 to the power anything, the answer is always a 1, so that is going to be out. Now this is n combination 2, and n combination 2 means n factorial divided by n minus 2 factorial and then 2 factorial, and that is equal to, okay, that is not equal to this. We are simplifying, and then here we're going to have x squared divided by n squared if we distribute the negative, I mean the squared. So n factorial means n minus 1, n minus 2. I'll end at n minus 2 and put a factorial because I've got n minus 2 factorial in the denominator, and then 2 factorial, and then we've got here, I can just say 1 n squared and then put x squared alone here. So we can see that the number in front of x squared is all this, that is the term. So what we can see is this cancels out with that. Okay, here we have got n squared, and 1n can cancel with 1, so we are just going to remain with n here, and then with a 2 down there. So what have we remained with? We have remained with, on top we have remained with n minus 1, in the denominator we've remained with 2, and then this n which is here. This is the coefficient of x squared, and we know it's supposed to be equal to 7 over 16. And here 2 can go into 2, 2 can go into 16. So we're going to have n minus 1 divided by n is equal to 7 over 8. At this point we can cross multiply. So what are we going to have? 8 multiplied by n, it will be 8n. 8 multiplied by 1, it will be 8, and that is going to be equal to n multiplied by 7, that will be 7n. I can take like terms to the one side. 8n minus 7n is going to be equal to 8. 8n minus 7n, that will be just n. So n is equal to 8. So that is the value then. And so that means the expansion is 1 plus x. Where there is n, I put 8, and then the power is also n, that is 8. Now I want to evaluate the coefficient of x to the power 3 in the expansion. So for us to evaluate the coefficient of x to the power 3, the expansion is the power here is 8, and then we want to have something to the power 3, so we need to put a 3 here. The first term is 1. We subtract 8 minus 3, that is a 5. The second term is x over 8. The same number which we have here becomes there. Okay. And so what we have is 8 combination 3. Of course this is the 1 to the power anything. 8 combination 3 means 8 factorial divided by 8 minus 3, that is 5. We put a factorial, and then the same 3 we are subtracting with, put a factorial, and then we can distribute the power 3. So that is going to give me, let me just write 1. Okay, let me put x power 3 and then 8 power 3. So 8 factorial means 8 times 7 times 6 and then times 5. Now that I've reached 5, I can put a factorial because I know I also have 5 factorial down. And then we also have what? 3 factorial. 3 factorial means the 3 times 2 times 1, and that is a 6. So 3 factorial is equal to 6. And then we are multiplying that by, on top I can just say 1. And then 8 cubed, I can say 8 times 8 squared. That's the same. And then I can say x to the power 3. Like that. Well, we have got 5 factorial, got 5 factorial. We have got 6, we have got 6. We have got 8 here, we have got 8 there. Okay. So what do you remain with? On top we've remained with 7, down we've remained with 80 squared. And 80 squared is just a 64. So this is 7 over 64. So the coefficient of x to the power 3 in this expansion is 7 over 64. Well, thank you so much for watching the video. We're going to continue with more solving. Stay blessed.